The squeeze theorem is applied a lot of times when you have either like a trig that you can't really solve for, or even a three-part inequality that's pre-set up for you a lot of times, okay? So for example, if I gave you something along the lines of, the limit as x approaches 0 of x squared sine of 1 over x. If you start by substituting, by plugging in, you're getting like 0 and then sine of 1 over 0, because, 0 squared is 0. And you might be like, okay, the answer is 0. And while that might look true, technically this is undefined, and sine of undefined, you can't really just call it and ignore it, okay? So that's kind of out. So what we're going to see is we're going to start with something that we know. We know sine of anything right there. We know sine of anything is going to be between -1 and 1. Sine and cosine curves, they oscillate between -1 and 1. If it was sine squared or cosine squared, it would be between 0 and 1. Make sure to write those facts down. Sine and cosine are between -1 and 1. Sine squared and cosine squared are between 0 and 1. Now we're going to go ahead and add more to it. Multiply everything by x squared. Because if this is true, I can multiply everything by x squared, and this will hold true as well. Now we're going to add this piece. Because if that holds true, I want to take the limit. So just notice I'm starting with the most basic fact. I'm just rebuilding everything along the way. Because what the squeeze theorem states is basically if both ends give you the same answer, then it squeezes the middle to only one possible solution. So on the left-hand side, you directly substitute in and you get 0. On the right-hand side, you directly substitute in and you get 0. So therefore, the middle has got to equal 0. So you basically say, you don't write 0 here. That's not technically correct. You could write the limit again if you want to, or leave it blank. But you'd say, okay, the limit as x approaches 0 of x squared sine of 1 over x is equal to 0 by this process known as the squeeze theorem. Is squeeze it to one and only one answer, okay? And again, this might occur with either trig, a lot of times sine and cosine, or a three-part inequality. And they have to be the same number. If they're not the same number, well, then you can't figure it out, okay? So basically, if you're given something along the lines of an inequality where, let's say, what if you got, let's say the answer was like 0 and 1, well, then the squeeze theorem would not apply. You'd be like, I can't figure it out using the squeeze theorem here. It's not going to give me an answer that I can justify. But in some other cases, you may. Just depends on a case-by-case basis. But this is the process. Basically takes 1, 2, 3 to 4 to get to the squeeze theorem and show your work.